Good day, fellow. Today we are going to continue with the concept of force. Last time I said to you that the weight force implies push or pull. See, we said that the concept of force can be divided into contact force and non-contact force. Non-contact force. Still remember, I gave you some examples. Under contact force, we said we have a normal force, applied force, friction, and tension. Under this one, we said we have a gravitational force, magnetic force, and electrostatic force. You see? Then for today, we are going to consider mostly the normal force and also the gravitational force at an inclined plane. See? Suppose if now I give you a plane like this, I also give you a box, let's say of mass 5 kg. Then firstly, I ask you to draw the free body diagram of this diagram. How will you draw it? It's so simple. On this diagram, we have two forces, the weight and the normal. Force is always perpendicular to the surface, inclined surface in this situation. And don't forget that we use this formula, W is equals to mg, to calculate what? The weight. You see? Let's say if it was 30 degrees here, we use this formula to calculate the weight. Suppose if now I decide to ask you to calculate the weight, parallel component, and also perpendicular component. How are you going to do that? You must know that this diagram can be further be written in this format now to say, okay, we are going to have the parallel component and also perpendicular component. This angle over there is going to be θ. You see, for us to calculate the weight is so simple. We only use this formula to say now W is equals to mg, our mass is 5, then gravitational acceleration is always 9.8. Then let's see, 5 multiplied by 9.8, we get 49 Newton. So simple. Now let us figure out the parallel component as well as the perpendicular component. For us to determine the parallel component, check this component, it is opposite to that angle. We are going to use sine. Do you still remember saw or scissor? Going to be W parallel, which is equal to our hypotenuse, which is weight in this case, you see, which is weight. Then we are going to substitute 49, or let me just start by saying W sine of 30 degrees, where you see W is this value, which is 49 sine of 30. So simple. 49 sine of 30, we get 24,5 Newton. Immediately after doing this, we can also calculate what now? The perpendicular component. As for perpendicular component, we use cos of 30. You see, then it's going to be 49, but this time around cos of 30 degrees. Let us calculate 49 cos, 9 cos of 30. We are going to get 42,4 Newton. Let me remove the weight from this diagram. I'd have now a diagram which is like this. If I were to remove the weight and leave out the components, I'm going to have something which is like this. This is going to be my normal force. Then somewhere there is going to be my W parallel. Bear this in mind. The perpendicular component together with the normal force, they are going to be equal but acting in opposite direction. We see such forces, they are at equilibrium, or they are at equilibrium. They are equal, yes, but act in opposite direction. We can then say, for us to find the normal force in this situation, we are going to say our normal force is equals to W perpendicular. Why? Because those forces, they are equal, you see, but acting in opposite direction. Then we got 42. Same applies as for our normal. It's going to be 42,4 Newton. You see, it's so simple. It's like last time when we were dealing with the flat surface. We found that for weight on a vertical scale, if we consider these two forces acting on this block, they always be equal. They are always going to be equal. Why? Because they are at equilibrium to one another. You see, same applies to this one. They'll also be equal. Then that's how we can then now do what? Find the weight, parallel component, perpendicular component together with what? The normal force on an inclined plane. You see, I thank you, my fellow, and kindly don't forget to subscribe if you are new to this channel. Then yeah, sure.